Hi, thanks for tuning in and watching this. We're going to walk through what coordinate graph is and what coordinate points are and how to use them and how they work and all this other fun stuff. But you are definitely going to need some paper. So pause this if you don't have some paper and a pencil right now, or a pen is fine. And I mentioned in an email to your families that graph paper would be handy, but don't worry if you don't have any, because I'll show you how you can use just regular old paper. So pause this again and go grab yourself some paper and a pencil or pen and come back when you're ready. Okay, so if you have just plain old line paper, kind of like I have here, it's okay. It's not perfect, but nothing that we're doing right now is going to be perfect. We're trying to get an understanding of what's going on and how this stuff all works. So I would probably start with just draw again as straight as you can. Doesn't have to be perfect, and if your paper has a red line down the side, you can use that to help. But just draw a line down the left-hand side, okay? And then where you stopped, you're gonna draw a side-to-side line, a horizontal line. Again, and you can use the lines around the paper, obviously, to try to make it as straight as you can. Okay, so we have these two lines on. These are important lines. This one that we just drew, the side-to-side one, the horizontal one, has a name, and it is called the x-axis. Sorry, my handwriting isn't great. This pen isn't the nicest to write with. And then the first one we drew, the one that goes up and down, is the y-axis. Okay, so we just drew the x-axis and the y-axis. And if you don't have graph paper, we've got the lines going side to side that will help. So you can, if you want, you can kind of mark them off. You don't have to, but it does help to kind of see what's going on. And then as best you can, just kind of estimate lines going up and down, lines going vertically that are about spaced out about the same as the ones going side to side. Doesn't have to be perfect. It's okay if it's not. We're just trying to make a graph, as close to what a real graph would look like as possible. And does this remind you of your homework from last week, playing Battleship? I hope it does, because that was the whole point. We're trying to get an idea of this concept of coordinate graphs, and that's all Battleship is. It's a game played on a coordinate graph. We just never called it that. So that's how you can just turn regular old paper into decent grid or graph paper. I'm actually going to switch over here, and I have my graph paper so everything's all nice and straight, and it'll work out a little nicer. So again, I'll label this down here. This is the x-axis. I'll try to squeeze this in here. This is the y-axis, okay? And you don't have to mark, but I do kind of like seeing them a little more clearly. It just helps. And, I'm going to label every other one just because I can't squeeze in every number. I wouldn't be able to fit them in with this pen. So I can do the same thing going up. I'm not going to actually label them just because my label of the y-axis will get in the way, but you understand that every line is just one. So just like when you played Battleship, if you picked A3 or B6 or E1, you knew to go down, to the letter and then over the number, and that's where the ship may or may not have been. And that's how coordinate graphs work. Let me switch colors here, because this point right here, where the two lines meet, where the x and y axis meet, is a very important part, or a very important point, I should say. This is called the origin, okay? And just like a comic book character's origin story, that's kind of where they come from. So the origin is where everything comes from. We always start there. So if when a coordinate graph, we use two numbers. So if you hear the numbers 4 and 3, and we write them like this, where you just kind of separate them by a comma, what this tells you is you're going to go over 4 because that's the x-axis, and then you're going to go up 3 because that's the y-axis. And you start at the origin down here in the corner. So the 0.43, you'd go over 1, 2, 3, 4. You don't have to put those dots there. I'm just showing you what's going on. And then you're going to go up 3. 1, 2, 3. So this point right here is the point 4, 3. So maybe we'll call that point A. So we can label it A. Maybe I'll try to get some of those extra dots out of here just so it's not quite as confusing. Okay, but that's really all we do when we plot points. Let's pick a different color here, and let's make the point, oops, sorry. We're going to use the point B. We'll call that point 3, 3, because yes, you can have two of the same number. So that means you go over 3, so 1, 2, 3, and then up 3, 1, 2, 3. So I'm going to kind of try to squeeze it in right next to A. So that is 0.33. All right. And we'll just do one more here. We'll call it C because I'm really good at coming up with clever names. We're going to call point C, we'll call it 5, 0. So that means I'm going to go over 5 because, again, that's my x coordinate. But I'm going to go up 0. I'm not going to go up at all, and that is totally allowed. So I'm going to go over 5. 1, 2, 3, 4, 5, and then nothing to go up. So that point right on the x-axis is point C. And I know I'm kind of squished in here. Hopefully yours isn't quite as messy and compact, but that's all coordinate graphs really have to offer in terms of how they work. So it's a lot like Battleship. Just think of Battleship. You're going to go over and you're going to go up. Okay, that first number tells you how far to go over, and the second number tells you how far to go up. Okay, and we will get into this more. This is our introduction. So again, pause this, rewatch it, make sense of it, and we'll continue with this at another time. Thanks for watching.